Really? Really? Y'all see this? Put your phone away! Sir, you scared me so much. Okay, mister. Since you want to text and Snapchat in class, tell me what 2 pi over 3 radians is in degrees. 2 pi over 3 radians? Pi? You want me to go get some pies? No, I don't want you to go get some pies. Sir, I don't know how to do that. Go ahead, I'll wait. I can't go get pies, but I got donuts. Will that make you happy? Really? Really? Now pay attention. Yes, sir, I'll pay attention. This video here has 3 objectives. The first, we want to actually figure out what a radian is. The second objective, we want to figure out, is there a conversion factor between radians and degrees? And then the third objective is simply practice converting from radians to degrees and from degrees to radians. To figure out what a radian is, I want to first draw a picture of a circle. In that circle, I want to label a radius. We'll label that radius R. I want to know the radius over here, R. All right, those 2 radii form something called a central angle, which is an angle in the center of a circle. And that angle intercepts this portion of that circle, and we're going to call that the arc, all right? And so we'll label that S for now. What's really cool about these 3 quantities in this circle is they are all related to each other in some sort of way. And so that relationship looks like this. Theta is equal to the arc length divided by the length of the radius. But what's important about this relationship is theta has to be in what's called radians. So what 1 radian is the measure of a central angle that intercepts an arc that is equal to the length of the radius. So in other words, if S equals R, then we could say theta, which is equal to S over R. Since we're assuming S is equal to R, we can substitute R in for S and have R over R, which reduces to 1. And we just say 1 rad or 1 radian. All right, so the next question we want to answer is, what is the conversion factor between degrees and radians? So they're related in some sort of way because they both measure angles, right? They're both some angle measurement. Well, the circumference of a circle is the length or the distance around that circle. The circumference formula looks like this. And so if we know the radius of a circle, then we can find the distance around that circle. So let's say we have a circle with radius 1 inch. If R equals 1, then the circumference would equal 2 pi times 1, or just simply 2 pi. All right, and we want to keep things exact. So that means don't go to your calculator and type in an approximation for pi. Don't type in 2 times pi and approximate what you get, which will be about 6.28. So we don't want to do that. We want to keep everything exact. And the only way to keep these measurements exact is to keep the pi unit within the answer. Okay, so don't approximate. All right, so the length around a circle with radius 1 is 2 pi. If I'm looking at this same circle and I say, well, the distance around this entire circle, which we just said was 2 pi, the arc length there is 2 pi. The radius is 1. Well, anything divided by 1 is itself. And therefore, we'd say that central angle in radians is 2 pi radians. So why is that significant? Well, that tells me to take a full rotation about a circle, or 360 degrees. Let me color this orange. So a full rotation about a circle, which we all know is 360 degrees, we could also say that that is 2 pi radians. Okay, so that central angle that intercepts an entire circle, or let's say the arc is the entire circle, that central angle is 2 pi radians. That tells me that if I know 360 degrees is equal to 2 pi radians, 360 degrees divided by 2 is 180 degrees. 2 pi divided by 2 is pi. There is your conversion factor between the two units of measure. 180 degrees is equal to pi radians. Halfway around a circle, you could either say that you're taking 180 degrees, or you can say you're taking pi radians. All right, so objective 3. Now let's look at some examples. If I have a 120 degree angle and I'm asked, okay, what is 120 degrees in radians? I want to multiply by a conversion factor between radians and degrees, which we just learned 180 degrees is equal to pi radians. All right, and so since they're equal to each other, that means if I divide one by the other, I should get 1. If I want to take 120 degrees and convert it to radians, what I want to do is obviously get rid of that degree unit. Well, if my degree unit is in my numerator, I need to cancel it out by putting a degree unit in my denominator with the conversion factor. Whatever I'm multiplying by, the unit in the denominator must be degrees. All right, so if I put 180 degrees in my denominator, specifically in my denominator, to cancel out that degree unit, then in my numerator, I'm going to put pi radians, or just pi. We'll stick the word radians or rads at the end. So the degree unit, of course, cancels out. So I have 120 pi over 180. Reduce the fraction 120 over 180, which, if you reduce that, well, you can reduce it in steps. If you know immediately what that reduces to, then go ahead and reduce it. And now the GCF between 12 and 18 is 6, and therefore this can be reduced to 2 pi over 3. So 120 degrees is equal to 2 pi over 3 radians. All right, so we want to convert 5 pi over 6, which is a radian measurement, to degrees. Well, we're going to take 5 pi over 6. We're going to multiply it by the conversion factor. We know 180 degrees is equal to pi radians. So this time I want my pi radians to cancel out. Well, pi is in my numerator in the problem that I have that I'm trying to convert. So I'm going to put pi in my denominator. What do I put in my numerator? Well, I put 180 degrees. And so what happens is the pi unit cancels. So I have 900 degrees over 6. And so 900 over 6 is equal to, and that's how you convert between degrees to radians and radians to degrees. If you have any questions, let me know. Otherwise, I'll see you in the next one.